Cheops stands for Characterising Exoplanet Satellite, and it's a small mission in ESA's science program. It's very exciting because what we'll be doing is following up on known exoplanets. More than 4,000 have been discovered to date in the 25 years since the first exoplanet orbiting a Sun-like star was found, and Cheops provides us with an opportunity to do some first-step characterization. We'll be studying some of the smaller planets, so planets, so-called super-Earths, so Earth to Neptune-sized planets, and looking to understand better what they're made of and how they form and evolve. And this is one of the steps towards perhaps the ultimate question that we ask ourselves as a civilization, and that is, are we alone? It's been a really interesting project to work on, fast, unlike some of ESA's larger missions, which have much longer timescales. I've been involved from not quite the beginning, but from about 1.5 years since the mission started. And so what is really nice is I've been involved in the development, and I'll be working now on the operations. So we'll be starting to see the first results come through in a few months' time. And I guess it's really looking forward to launch and watch this space. First of all, making sure that the satellite survived the launch and that the instrument performs as we expect it to and we need it to. And then once we've established that everything works and works well, we'll be able to start doing the science. And that'll be very exciting, following up on some of the targets which have been shown to be very interesting by other missions, but Cheops will put the icing on the cake. The science program of Cheops is defined by the science team of Cheops, so from the consortium. 80% of the time goes to them, but 20% is open to the worldwide community at large. If you have a good proposal, you can apply for time, and if it's of high scientific merit and you make good use of the capabilities of Cheops, Cheops will give you time. Very exciting opportunity for scientists at large. What's my favourite exoplanet? That's an interesting question, because you could say that the first exoplanet to be found, hot, puffy, gassy Jupiter-like planet, is a very interesting planet, but also the smaller planets, rocky, lava worlds. It's difficult. There's such a wide range of planets that have been discovered. All sorts of sizes, masses, temperatures, orbits, all very, very different from those in our solar system. It's a difficult choice. It's like opening a chocolate box and you asking me which is my favourite chocolate. I like all chocolate, milk chocolate, but choosing which one to go for first is a difficult one. So I'll think about that one. So with Cheops, we use the technique of transit photometry, and that is to monitor the light from a star as the planet moves between the star and the observer. So maybe I can show this with a pumpkin, which I picked from the garden, and a couple of different pieces of fruit. So here we have our star, our planet. What we do is monitor the light as the planet moves across the disk of the star. Okay? So what the planet does as it moves across the disk is to obscure part of the light from the star. The bigger the planet, the more light it obscures. You can see this here looking with an apple. So the smaller the planet, the less of the light that we block, and so the more difficult it is actually to measure the transit depth because it's smaller. And that's actually the benefit of Cheops. We'll be looking at these smaller planets, and because we'll be following up, we'll be able to come back to the planets, the star and its planets, each time the transit occurs. We'll be able to observe all sorts of transits around the sky and come back at this critical period as the planet moves across the disk of the star. What we can also do is measure the so-called phase curve of a planet. And so what we're doing there is measuring the output of the light from the star as the planet moves the whole way around the orbit. So what we're doing there is measuring the reflected component of the light from the planet, as well as the dip caused by the obscuration of the star by the planet. And from this phase curve, we're able to find out quite a bit about the dynamics of the atmosphere.